Now that we've talked about how steel poles are manufactured and their differences from wood poles, let's spend a few minutes talking about how poles are framed and set. For this, we'll join a crew in the field as they work to frame a new steel pole and prepare it to be erected. During the tailgate session, the crew plans how the job will be done and crew assignments are made. As with any distribution job, you should always wear the appropriate personal protective equipment, including work gloves, proper footwear, eye protection, and a hard hat. The crew has decided that 2 of the men will dig the hole while the rest of the crew works to frame the pole and prepare it to be erected. The line crew have decided to frame this pole on the ground before it's erected. Because steel poles are consistent in size, the hardware needed for framing a steel pole can be predetermined with no need to allow for the type of dimensional variability found in wooden poles. This simplifies the line worker's job as they frame the pole. For the most part, steel poles can be framed using the same hardware as a wooden pole, with a few minor differences. For instance, cleated grid gains should be replaced with smooth gain plates. In general, the same standard types of arms and hardware used on wooden poles can also be used on steel poles. Arms can be made of steel, fiber-reinforced polymers or FRP, such as fiberglass, or even wood. FRP are increasing in popularity because they are made of a non-conductive material, mitigate some of the problems with wildlife, and outlast wooden crossarms. They are also easier to handle since they are lighter weight. The crossarm is installed on the pole using a through bolt. An oversized washer is used on the opposite side to help distribute the load from the nut and bolt head. These washers are either curved or flat, depending on the cross-section geometry of the pole. There has been some debate about how tight bolts should be tightened on a steel pole, but experience has shown that the best technique is to make bolts snug tight. However, there is little risk to over-tightening bolts. Most poles are stiff enough that it would be difficult to alter the pole's shape by applying too much torque to the bolt. An added benefit of using steel poles is that since their size doesn't vary with environmental conditions, equipment rarely needs to be retightened over time. Most poles are pre-drilled at the factory for framing and climbing, but poles may also be easily and quickly drilled in the field. Because steel poles have a hollow cross-section, the most common method of drilling new holes is to drill 2 new holes in the pole 180 degrees apart from one another. Though in some cases, a long bit extension is used to drill completely through the pole from one side. The line workers first measure and mark the location of the first hole to be drilled. After the first hole is drilled, to ensure that the hole on the opposite side is in the correct position, the line workers use the string method. To use the string method to determine hole placement, a line worker takes a string and wraps it around the circumference of the pole. Then, the string is folded in half, with one end placed at the center of the first hole. The length of string is used to determine the position of the rear hole from the center of the first hole he's already drilled. The crewman makes the mark and drills the hole. Another popular option to attach hardware to a steel pole is the use of steel banding. Because steel poles swell and shrink very little with temperature change and moisture content, a properly installed steel band remains tight and works very well. Although less common, welded attachments may also be used on steel poles. The most common type of foundation for a steel pole is direct embedment, which uses techniques that are familiar to those who have installed wooden poles. The first step is to determine the size of the hole to be drilled. This pole is 55 feet long. The crewmen know that the depth required for a steel pole is the same as that of a wood pole, so they use the rule of thumb that a hole should be 10% of the length of the pole plus 2 feet to determine the hole depth. So in this case, the depth of the hole should be 10% of 55 feet, which is 5.5 feet, plus 2 feet, which means that the hole should be 7.5 feet deep. Next, the line workers determine the diameter of the hole. While a wooden pole may vary as much as several inches in diameter from one pole to another, steel poles are consistently the same diameter from one pole to another. This means that in most circumstances, the hole diameter is about the same as the ANSI specified minimum diameter for a wooden pole of equivalent strength. This minimizes the amount of backfill needed for the pole. The crewmen have finished digging the hole and have stowed the auger back on the boom. They are now ready to lift the pole. Steel poles can be lifted up in most cases from a single point pickup. The balance point of the pole needs to be determined so that it can be rigged properly. Unlike wooden poles, steel poles are not butt heavy and have a more consistent weight over the length of the pole. The crewmen mount a sling just above halfway down the pole. It is recommended to double choke the sling in order to prevent slippage. The pole is lifted and the line worker tests the balance of the pole to ensure that it is slightly butt heavy and will rotate to a vertical position as it is raised. The operator opens the jaws on the hydraulic pole grabbers on the end of the boom and adjusts the pole grabber angle to receive the pole. The pole is slowly raised with the winch lines. As it goes up, it swings into a vertical position as the man on the ground helps to guide and stabilize the pole. When the pole is fully vertical, the pole grabbers are closed to prevent the pole from swinging uncontrollably. The butt of the pole is now directly over the hole. The operator lets out the winch line as the man on the ground guides the pole into the hole. The crewman on the ground observes the pole from two different positions to ensure that the pole is plumb, providing hand signals to the boom operator as appropriate to adjust its position. In this case, the pole's position needs to be adjusted to be in alignment with the poles farther down the line. The line worker uses a nylon strap to turn the pole and adjust its alignment. When the crew is satisfied with the pole's alignment, the boom is used to hold the pole into position as the crew backfills the hole. The placement of backfill around the steel pole is generally no different than that of the wooden pole, but good tampering procedures should be used and care should be given to not damage the protective coating if applied. Now, in some cases, you may be setting a pole in a confined area with obstacles such as walls, trees, or fences that restrict positioning the new pole during installation. The lighter weight of steel poles makes them easier to handle in these cases. They can be placed on an easy hauler or similar device and maneuvered into confined spaces, or if need be, they can be carried on the shoulders of a gang of strong line workers. Before we move on, let's go over grounding procedures for steel poles. There are a few important differences to note when it comes to grounding a steel pole. First, it's important to remember that, like wood, steel is a conductive material. This has several advantages, such as the steel pole itself becoming a ground for lightning strikes and other faults, but the conductivity can be a concern in some situations. Another clear advantage is that there is no need to run a copper ground wire from the top of the pole to the bottom. This saves the utility time and money. It also eliminates the risk of vandals stealing the copper wires. There's also little chance that there will be a loss in the electrical ground. For the job that's being illustrated, the line worker needs to ground pole top equipment. He does this by inserting a grounding nut on the pole at the point near the equipment. Threaded inserts or grounding nuts may be placed anywhere along the pole where bonding attachments need to be made. Now, since the base of most steel poles has a protective barrier coating on the embedded portion, it is considered to be electrically insulated from the soil. Therefore, some means must be provided to ground the base of the pole. One way to do this is to drive a copper ground rod into the soil and connect it to the pole via a short ground lead to a grounding nut welded to the pole just above the ground base soil line. Another method is to simply refrain from using an insular barrier coating on a short section of the bottom of the pole or bearing plate. These types of grounding provisions are per the guidelines of the NESC. However, before doing this, you should consider the long-term consequences if this area of the pole should corrode. Now let's go to another crew as they prepare to set a pole in a situation that's a little bit different. In this case, the line workers need to set a pole where other energized lines are a factor. Remember, some of the specific procedures you see, such as grounding the pole, may vary between companies. Be sure to follow your company's guidelines. The first thing they do is select a location for the new pole that will best support the transfer. They discuss this and safety considerations at the tailgate meeting. They create a work plan, and since work will be going on around energized lines, thoroughly review the site safety considerations for anything that might be a problem. Because of the energized phases, the crew will not frame out the pole until after it is set. Additionally, this company requires that both the truck and the new pole be grounded to the system neutral. Since contact between a pole and any energized source will also energize the pole, cover gear is used on the phases and the system neutral to insulate the work area. And the workers are sure to wear the appropriate rubber protective gear. The workers also put pole guard on the areas of pole that might be exposed to the conductors to prevent the pole from contacting any of the conductors as it's raised into position. After positioning the pole, the crew adjusts the sling to just above the halfway point for lifting. Again, the workers use a double choke method to ensure that the pole doesn't slip while it is being raised. The operator begins raising the pole. As it's lifted, a worker wearing rubber protective gear maneuvers the pole around any obstacles. Once the pole is in place, it's aligned and plumbed, and the hole backfilled as it was before. The crew is now ready to frame the pole and move the energized phases into place.